All right, today we're going to dive into a story that's so old it has no words. It's a history that wasn't written in books, but in stone, in ancient bone, and really, in the very fabric of our DNA. This is the story of where we all come from, our incredible prehistoric journey.
So that's the big question, right? If nobody was around to write anything down, how in the world do we know what happened millions of years ago? Well, it means we have to become detectives. We have to piece together this giant, epic puzzle from the few clues the deep past decided to leave behind for us.
Okay, so let's get our terms straight. Prehistory. It just means this huge, almost unimaginable stretch of time before writing was invented, which happened around 3200 BCE. So our library for this period isn't filled with books. It's a collection of fossils, the preserved bits of ancient life, and artifacts, especially the stone tools that our distant ancestors left behind. For most of human history, the origin story was pretty simple. The idea was divine creation, that all life was made perfectly, exactly as it is now. But then, starting around the 1800s, this massive shift in thinking starts to happen. Scientists started finding fossils of creatures that just didn't exist anymore, which didn't fit the old story. And it led them to a pretty radical new idea. What if life isn't fixed? What if it's constantly changing?
So this new way of thinking was great, but it needed a mechanism. It needed an engine to actually make it work. And that brings us to what is, without a doubt, one of the most powerful ideas in the history of science. The man who figured out that engine was the English naturalist Charles Darwin. In 1859, he published his game-changing book, The Origin of Species. And in it, he laid out this beautiful, elegant theory he had developed over years and years of observation. He called this engine natural selection. So how does this work? It's actually super simple but incredibly powerful. Take the classic giraffe example. First, you've got variation, an ancient herd of giraffes, some with slightly longer necks, some with shorter ones. Then you've got pressure from the environment. The best, tastiest leaves are way up high. So who gets to eat more, live longer, and have more kids? The ones with the longer necks, of course. And they pass that winning trait down to their own offspring. Over millions of years, the whole species changes. It's not magic, it's just survival of the fittest. Okay, so that's the theory. How does this all apply to us? Let's zoom in on our own family tree and see how this process built the very first, and maybe the most important, piece of what makes us human. Our own story, our split from the other apes, really begins here. We're talking over 4 million years ago in Africa, with this character, Australopithecus, which is a fancy way of saying southern ape. This was one of our earliest ancestors, a hominid that took the first world-changing step, and I mean that literally. So, why was walking on two legs, being bipedal, such a total game changer? Well, for starters, it gives you a higher viewpoint to spot predators. But the real revolution, the absolute genius of it, was this. It freed up the hands. I mean, think about it. For the first time in history, hands weren't just for walking anymore. Now they could carry things, they could defend, and most importantly, they could start to use tools. This was the spark that lit the fuse for everything to come. And believe me, those free hands are about to get very, very busy. This is where we see that powerful conversation begin between our hands and our brains, a conversation that basically defines our entire story. Okay, let's fast forward a couple million years. Now we meet the first member of our own genus, Homo. This is the group that leads directly to you and me. And this guy is Homo habilis, nicknamed Handyman. And trust me, he earned that nickname. This was a major, major leap forward. So what made Handyman so handy? Well, physically, he had a much better opposable thumb, which allowed for a precision grip, but the real magic was happening inside his skull. His brain was bigger, and it could do something amazing. It could plan. It could visualize a tool before it was even made. He'd pick up a rock and purposefully chip away at it to create a sharp edge, making the first real tools we call choppers. The brain imagines, the hand creates, and in turn, that act of creation makes the brain even smarter. Building on that foundation, about 1.8 million years ago, another major player steps onto the world stage. Homo erectus, the upright man. And just like the name says, these guys had totally mastered walking on two legs. And Homo erectus was a master of its environment. Their tools got way more advanced. They made these beautiful, symmetrical, teardrop-shaped hand axes. They were also true pioneers. Erectus was the first of our ancestors to actually leave Africa and spread out into Asia. And, maybe most importantly, they learned how to control fire. That's huge. Fire means warmth, protection from predators, and cooked food, which unlocks way more nutrients and just keeps fueling that ever-growing brain.
All right, let's move to the final act of this prehistoric drama. The stage is now set for the arrival of hominids, who were, in so many ways, just like us. Now, we've all heard of the Neanderthals. Between about 200,000 and 100,000 years ago, these famous evolutionary cousins of ours were thriving all across Europe and Asia. And they were incredibly tough, perfectly adapted to the cold climates of the Ice Age. And you really need to forget that old brutish caveman stereotype, because it is just plain wrong. The evidence we have today shows that Neanderthals were incredibly sophisticated. They made complex tools, built shelters, they even made clothing. And maybe the most profound thing of all, they buried their dead. That strongly suggests they had some kind of symbolic thought, maybe even spiritual beliefs. But here's the thing, they weren't alone. For thousands of years, Neanderthals shared the planet with another human species that had just recently arrived from Africa. And this sets up one of the greatest mysteries in all of human evolution. Why is only one of us still here today? That newcomer, of course, was Homo sapiens sapiens. It was us, anatomically modern humans with the same bodies and the same brains that we have right now. So, what was the difference? Why did we make it and they didn't? Well, this table really highlights some key things. While both species were clearly intelligent, it seems sapiens had a kind of creative technological edge. Our toolkit was just more diverse, more specialized. We developed things like sharp arrowheads, fine stone chisels, even bone needles to sew fitted clothing. Now, the exact reasons are still debated, but around 40,000 years ago, the Neanderthals just vanished. And they left Homo sapiens sapiens as the last human species standing on Earth. So if you take one thing away from this entire journey, it should be this idea of an incredible feedback loop. It's so important. The more our hands could do, the more it stimulated our brain to grow. And the smarter our brain got, the more complex things our hands could create. This cycle, this perfect partnership between our thoughts and our actions, is literally what built our world. And that brings us to today. Our evolution, this long story driven by winning traits and adapting to pressure, has taken us from the African savanna to every single corner of this globe. And it leaves us with one final, pretty fascinating question to think about. In a world that we have so completely reshaped ourselves, what's the next winning trait going to be? What is humanity's next evolutionary step?